So hi guys, today's question is number of recent calls. And now this is a really easy question actually. What the question says is that imagine you have a server. So the user can send requests or calls to the server, right? Which is kind of like receiving notifications on your cell phone, right? So, what the question asks you to do is basically keep track of the total number of calls, a total number of recent calls. Now, what do recent calls mean? All the calls that have happened between the current time that this current call is happening at till 3 seconds or 3000 milliseconds before the current time are considered to be recent calls. Okay, so any call between this time period, both ends inclusive, is a recent call, and all we have to do is keep track of the total number of recent calls. So this is posed as a design problem, which means we need to complete this class called recent counter. So the constructor just has to initialize our so-called counter with 0 recent requests, and the ping function shown here uh, takes an integer input called t, which is basically the current time at which this current call is being pinged. Okay, this current request is being sent, and it should return the total number of recent calls that have happened between this current time and this current time minus 3 seconds. Okay, so how do we approach this problem? Now, one nice way would be to just keep an array and uh, keep the time of all the calls that have been made in this array. And whenever a new call is made, you just look for the time that is more than 3000 seconds before the current time. So you look for the last time that is less than 3000 seconds before 3000 milliseconds before the current time, and you count the number of elements between from that index till the end of the array, and you just return the answer, right? But the problem with this approach is that you'll waste a lot of memory, because you'll keep track of all the times of all the calls that have ever been made to your server, right? But actually all we need to do is just keep track of the recent calls that have been made to your server, because all we need to return is the number of recent calls. So any call that happens before t minus 3 seconds, where t is the time of the current call, is an outdated call, and we don't need the information for its time anymore. We don't need any information regarding that time period anymore. So we can do away with that, right? So the way to model this easily and solve this problem is using queues. Let's shift to the blackboard and see how.
Okay, right. So what we're going to do here in this algorithm is maintain a queue, right? And this queue is going to have only and only the times of the recent calls. Okay, so it's only going to have the information about the calls that have happened between t, which is the time for the current call, and between t minus 3000 milliseconds. So and that is how we have to maintain this queue. So we have to write our algorithm in such a way that this is our invariant throughout the entire algorithm, that the queue only and only has information about the recent calls, right? So every element of the queue will just be one recent call that was made to the server. And if this is our invariant, what we can see easily is that the length of this queue will just return the number of recent calls, right? So giving the answer to these ping functions would just become really easy. We'll just be able to return the length of the queue. Now let's just see how this algorithm is actually applied. So the actual input to this problem will be in the form of method calls to our class, right? Because what we have to design is a class. So the first method call will just be this recent counter method call, which is like the initializer function. So this should just set our so-called counter for recent calls to 0. So in this, all we need to do is make a queue that is empty, right? That's all we have to do for this whenever this method is called. Okay. Now the other thing, the other methods that will be called are just the pings themselves, which means the calls themselves. Okay. So what are we going to do? We're supposed to remove the updated. We're supposed to remove the outdated calls from the queue and add the recent calls. Okay, that's our basic strategy. So let's just see how we're going to do that in an algorithmic way. So whenever we receive a ping with the time given inside it, we first try to look at the front of the queue. But if the queue is empty, then obviously there is no front, so we can just directly add that time to the queue, right? So we should just directly store the time for that ping to the queue. Okay. Then whenever the ping method is called again with, so say this is the input, so 2000 is called, right? In this case, what we have to do is that look at the front element of the queue. So look at so peek into the queue and check this, that this front element of the queue should be at a time that is greater than t minus 3000 seconds. So greater than 2000 minus 3000 seconds, and 32 is in fact greater than 2000 minus 3000 seconds. So therefore we don't need to pop it off because it's not outdated anymore. So in such a case, we just append 2000 to the queue and move on. That's all. Okay. Now let's look at our next function call. So that's 353. That happens at 3537, right? So again, look at the front element of the queue and check if it happens before t minus 3000. So here 32 obviously happens is a time that is before 3537 minus 3000. So in that case, this becomes an outdated call, right? 32 becomes an outdated call. So in that case, we should just remove this, remove it, pop it from the queue, okay? And again, check the next, the new front element of the queue. So that's 2000. Now 2000 actually lies between t minus 3000 and t. It doesn't happen before 3537 minus 3000 seconds, right? So it's not an outdated call, it's a recent call. That's why we just append 3537 to the queue. Okay, that's all. And then let's move on to the next function call. So that's 5663, right? So for 5663, again, we check the first element of the queue, the front of the queue, and 2000 actually happens before the time t minus 3000, right? Before the time 5663 minus 3000. So it's outdated now, and we should just remove this from the queue. Okay, and then what we have to do is that check the next front element of the queue, right? So that's 3537 now. So 3537 actually lies between the interval t minus 3000 and t, right? 3537 isn't outdated, it doesn't lie before 5663 minus 3000, so it's a recent call. So we let it be in the queue, we don't pop it off, and we append 5663 to the queue. Okay, that's it. And so what will we be basically returning from this function? We'll just be returning the length of the queue, right? How I described before. So when this function is called ping5663, the length of the queue at the end of this function call is 2, right? So the answer to this would be 2, which means only 2 is the total number of recent calls that have been made, right? 2 is the number of calls that have been made between t minus 3000 to t milliseconds, right? Yeah. Similarly, we continue doing the same thing for the other function calls. So for 9321, we look at the front of the queue and we see that it's actually 3537, right? And 3537 obviously happens before 9321 minus 3000. So we pop it off, right? And then we look at the new front of the queue, which is 5663. 5663 in fact also happens before 9321 minus 3000. So we pop this off too. And now our queue has become empty, right? So in such a case, we can directly append 9321 to the queue. So let's just write 9321 here, right? And that's it. Now what will our answer be again for this function? It will be 1, because the length of the queue here is 1. So the number of recent calls that happen between 9321 minus 3000 milliseconds and 9321 milliseconds is just 1, which is the call that happened currently itself. Okay. Then we look at 10,000. All right. So for 10,000, we check the front of the queue, and 9321 actually isn't an outdated call because it doesn't happen before 10,000 minus 3000. It happens after that, right? So it's a recent call. That means that we just append 10,000 to the queue and return the length of the queue as the number of recent calls. So that's just 2, which means our answer is 2, right? This returning part is also done for the first 3 calls of the ping statement, which I didn't write explicitly here. But I hope you understand what the algorithm is. So let's move on to the implementation part now. Okay, so let's try to implement our algorithm now. So firstly, I'm just gonna import collections, right? Because I'm gonna try to model my queue with a DQ. So I'll need collections for that. Now, this init function is basically this recent counter initializer, which I talked about, right? Which is definitely has to be the first function that is called. Okay, so what this function is supposed to do is just make an empty queue, right? So that's really easy. We can just say that self.queue. We say the self because this is actually a class, so this is object-oriented programming. Yeah, so self.queue is equal to collections.dq, and yeah, that's all, right? Uh, that's all that we have to do in this init function. Just make an empty queue, right? Uh, our so-called counter about the number of recent calls will automatically become 0 because our counter is actually the length of the queue, right? And in this case, it will just be 0. Now, coming to our ping function. So what were we doing? We were continuously checking the front of the queue, right? To see if the call at the front of the queue happened at an outdated time or not, right? So, but also an important point here is that uh, if the length of if the queue is empty, then we shouldn't check the front of the queue, right? Because that would return an error. So here we should just write this loop that while the length of the queue, so length of self.queue is greater than 0, and the front of the queue has an outdated call. So if the front of the queue has an outdated call, that means the time for that call will be less than t minus 3000, right? And that's what we discussed in the algorithm too. So while this condition is satisfied, we need to keep popping the front element from the queue, right? So we just do self.queue.pop left, right? And that's all. And after this happens, we should append our current time t to the queue, right? So we do self.queue.append t. This puts our current time to the back of the queue, which is what we wanted. And after this, all we have to do is return the length of the queue, right? Because uh, because once these steps are done, our queue is now updated, right? So our queue only has only and only has the information about the recent calls made to the server.
So therefore the length of the queue will just be the total number of recent calls made, right? So that's all. The code is just that much. Let's try running this code once. Okay, so it gives an error saying that, okay, right. So over here I had to write self.queue like I was saying. This self basically refers to the class that we're in, right? Let's try running it now. Great. So it works well on the example cases. Let's try submitting it. Okay, great. So the memory usage is pretty good, and so is the runtime. Uh, let's talk about these explicitly here. So the memory usage is going to be as much as the maximum size of the queue can go till, right? And the maximum size of the queue can only become 3000, right? Uh, there are 2 points that go into proving this. One of them is that it is guaranteed that every call to ping uses a strictly larger value of t than the previous call, right? So if you call if you call at 200, you can't call at 200 again. It has to be strictly increasing, so it will have to be 201. And the other thing is that our queue always and only contains the information about the recent calls. So it only contains the recent calls within it, which happen between t minus 3000 to t seconds. So imagine that the first call happens at 1, and uh, every millisecond after that a new call happens till you reach 3000, right? So now your queue has a length of 3000. Now, when in the next millisecond another call happens, so at 3001th millisecond a call happens, uh, the this part of the code will run and it will pop off the front element. So it will pop off the first call that had happened at time t is equal to 1 millisecond, and then add the new element at time t is equal to 3001 only, right? So by the design of our very algorithm, the queue can only be have a max size of 3000 elements, and since this 3000 is a given number in our problem statement, therefore we can say that our space complexity is just big O of 1. Okay, it's not dependent on the input at all, just big O of 1, right? And regarding the time complexity, so what we're basically doing, so which part takes up the most time in our algorithm? It's this while loop, right? So in the worst case, what can happen is that our queue is completely filled, which means it has 3000 elements, and all of them have to be popped off of the queue, right? To make the length of the queue 0, right? In such a case, this while loop would run 3000 times, right? But that is the max that it can run till, because our queue itself can't hold more than 3000 elements, so we can't pop off more than that. So by that we can say that our time complexity is also big O of 3000. And again, since 3000 is a given number here, it's our time complexity is just big O of 1. If this 3000 was something like n, then our time complexity would be big O of n. But currently it's just big O of 3000, which is just big O of 1, right? Uh, yeah, so that's all. So that's all for this question. I also wanted to discuss some little things about this question, which are a little advanced. So only if some advanced people are watching, they can worry about them. Otherwise, if you want to skip this part, just feel free to skip it. So what I wanted to discuss was this: that since our queue is sorted, because every call to ping uses a strictly larger value of t than the previous call. So whatever this queue will be, it will be sorted, right? Strictly sorted. Uh, that means that we can easily use binary search to find the number that is just lesser than t minus 3000, right? So we don't have to linearly search like this, like we're doing in this loop. We can do a binary search, which would be big O of log 3000, right? Which is a better time complexity than what we have currently. But the problem there is that for a binary search algorithm to work in a big O of log n time, you need constant uh, access constant time access to any element in the middle of your data structure, right? So for example, when you use arrays, every element has an index, right? And that index allows you to retrieve that element in constant time. But in a queue, that is not what happens. If in a queue you want to retrieve some element from the middle of the queue, it will take you big O of n time, where n is the size of the queue, right? So we definitely can't use a queue for this binary search algorithm that I just described, right? So what can we then use? We can use an array, right? Because I just said that they have a constant random access to elements in the middle of the array. Uh, but if we use an array, we still have to get rid of the elements that we no longer care about. We have to get rid of the information about the outdated calls, right? And doing that in an array takes big O of n time again. So removing elements from the front of the array takes big O of n time, and that's why we won't be able to go forward with that binary search algorithm, because removing those elements, truncating that array after finding the element at where we should truncate it at, the index at which we should truncate the array at, that truncation will take big O of n time. Okay. uh, Now there is another method that we could use instead of removing those elements, we could use a pointer called front to denote the front of the array, right? So we just keep storing all the calls that come, and whenever we find the element at which we want to truncate the array at, so at which we want to remove the front of that front part of the array, we just shift this front pointer to that index, right? But in this case, we land up at exactly where we started off at, right? Because in this case, what we're basically doing is that we're storing all the not all the recent calls, but all the calls, each and every call ever in the lifetime of the server made to the server is stored in this array, and all we're doing is updating the front pointer, right? But that those calls that are outdated now are still present in the array, and they're still taking up memory. So that's why this just makes the space complexity of that algorithm very bad. Just Which is exactly where we started off, right? We started using a queue because we didn't want to store all the calls that are being made to our server, only the recent ones. And we could do away with the information for the outdated ones. Yeah. Uh, so that's all that I wanted to talk about. So in that case, using a binary search method, using a binary search algorithm becomes a little tricky, uh, because we can't find a data structure where it has random access to the middle elements, and also can easily pop off elements from the front of the data structure, right? So yeah. So that's all for this video. Thank you for listening, and I hope this helped. If you guys have any doubts, just feel free to leave them in the comments, and I'll definitely have a look at them. Thank you.